Welcome everyone. This is Professor Coppola broadcasting from the nation's capital. And what I'm first going to go through in this comprehensive review is something that I have posted in D2L under Final Exam Resources. Comprehensive review for final exam. So I'm going to open that baby up and then enlarge it. So the first thing I'd like you to do is to complete your course evaluation. It takes about 15 minutes. This is the direct link. I also sent you a correct link in your email. So please take care of that. Alrighty. So our final exam will be on Thursday, April 25th. And that should say 2024, so let me fix that for you. Okay, now it's fixed. We'll save it, and I'm going to put it correctly on your D2L. It'll be at 9 a.m. to 10:50, so it's 70 questions, 1 hour and 50 minutes. It's an American Chemical Society exam. The challenges are the questions are challenging, and your goal should be, excuse me for a minute to take a drink. Your goal should be to try to get as many questions correct as you can, and I want you to rise to the occasion. There's no question on that exam that you can't answer. Think of it like a basketball game or soccer match. You're going to rise to the challenge. You got a tough opponent, you can do it. You're going to have initial nervousness, which is fine, and then eventually you're going to settle down. Just like in the March Madness games and the basketball men and women, the first few minutes of the championship game, everybody was nervous, and then they settled down. So that'll happen. So just try to do the easier ones first, come back to the more difficult ones. Okay, remember. Okay, so there's our grading scale for the year. Your attendance, class participation, and professional development are worth 5%. Homework is 20%, laboratory 25%, quizzes 10%, exams 10%, exams 25%, and final exam is 15%. Okay, it's stuck a little, but let's try it again. And there's our grading scale that we're following. And remember to submit your professional development form. I've only received 4. That's half of your attendance grade. So please turn that in. Even if you didn't go to 5 events, turn in whatever you did. Okay, so this is what the front page of your exam is going to look like. Look to where the finger is pointing. Do not write anything in this booklet. Do not turn this page until your instructor gives the signal. A periodic table is provided. When you are told to begin, open the booklet and read the directions. Okay, I'm also going to provide you another periodic table, the one we've been using all year long because it's easier to work with. Okay, directions. When you have selected your answer to each question, blacken the corresponding space on the answer sheet using a soft number 2 pencil. I'll have a nice supply. Make a heavy full mark, no stray marks. If you decide to change an answer, erase the unwanted mark very carefully. However, you will be able to put a dash next to the question, which could be a signal to you to come back to it later. But on the actual circles, you should only fill in 1 circle. Don't make any marks on the test booklet. Do all the calculations on your scratch paper, which I'll provide you plenty. There was only 1 correct answer to each question. Any question for which more than 1 answer has been blackened will not be counted. Your score is based solely on the number of questions you answer correctly. It is to your advantage to answer every question. So if you come to the end of the time, just fill in all the with a guess. Use the same letter. Maybe you use the letter C. So just guess, and you're bound to get some of those right. And that holds true for any standardized exam. Okay, here's your answer sheet. All I'm going to do is ask you to put your name. In fact, I covered this over and just put name. Just put your name. That's all I need. You don't need to fill in anything else. And so it's going to be 70 questions. We're just going to go up to here and you fill in with the number 2 pencil. As I say, if you want to put a dash, that's okay next to it, just so a reminder to come back to it if you're not sure. Okay, so you can put a little dash next to it, but here you should only fill in one spot. All right, now this is going to be your reference page. All right, let's take a little look at this. So N is going to be the amount of substance, atmosphere ATM, Avogadro's number, K sub B, Celsius temperature, centi, activation energy, enthalpy, entropy, equilibrium constant, free energy, freezing point depression constant, K sub F, gas constant is R, grams is G, hours is H, joules J, Kelvin K, kilo is a little k, liter, capital L, milli is M, molal, remember molal, a little m, molar is capital M, mole, M-O-L. You're not going to deal with Pascal. Pressure, second, specific heat, capacity, remember that, usually we just use a little c, temperature, T, volt, V, not really going to work with that. And the volume is just a slanted V, K sub W, the dissociation constant for water. Measures of pressure, 1 atmosphere, 760 millimeters mercury, so that's given. Gas constant, remember there are two different ways to put it with different units, depending on the question, okay? Here it's liter, atmosphere, mole per mole Kelvin, and this is the PV equals nRT. And then in other types of problems where you're involving joules and moles and Kelvin, you're going to use that R. For Avogadro's constant, use the 3 decimal places, 6.022 times 10 to the 23rd. If you just use 6.02, you'll get close to the right answer, but if you want to get the exact right answer, use this. But in any event, you'll be able to find it on the choices given. Now, one thing about Faraday's constant, what they do is they put amp seconds. Amp seconds means a coulomb, and the way we did it in class was coulombs per mole of electrons. So this is the one that we used, okay? So this really is amp second means coulombs per moles per second. Then we have these equations. You won't have to use this equation. Here's our buffer, pH for a buffer. Remember that's the base, that's the acid. You won't have to use this equation. And then for remember finding the change in freezing point, that depending on I, K sub F, M, molal. Remember, I is the number of particles it breaks up into. Same thing for the boiling point. And oh, there's our beautiful equation. Delta G equals delta H minus T delta S, and that's going to tell us whether or not the process is spontaneous. And here shows the relationship between delta G and K, and that gives you, the free energy tells you what's the position of the equilibrium. Remember, that's natural logarithm RT, and or delta G equals N times F, and this is the voltage, the electric potential. Now these equations are in different forms, and if you want I can put it in the form, I will put it on the board, the form that we use, but this will still work. It's the same thing mathematically. For the first order, we didn't do any zero, and the second order. So if you have questions about that, I can help you, but I can put this in the form that we used in class and was on our reference pages, but this will also work. They're identical mathematically, and I'm not going to go through why that is, because it's not a mathematics class. Here's a periodic table that they provide. Okay, and I'll also provide you one. Okay, notice you got the atomic number at top. You should use the full number, in other words, all the decimal places. So for aluminum, use 26.98 for the atomic mass. For carbon, use 12.01. So use all the decimal places that are given, and that'll help you get the exact answer that they have for the choices. If you don't, you'll still be able to figure out which one is the correct one, because it'll be very close to the correct answer. Alrighty. Alright, here's study plan. Plan to get a good night's sleep the night before the exam, because you're going to have to think clearly and apply your knowledge. You should review all your exams for both semesters 4 for the first semester and 4 for the second semester, and they are posted on D2L. Then they will be posted, depending on when you listen to this, it'll be Wednesday afternoon. So you have your exam on chapter 19 Wednesday morning, and then Wednesday afternoon I will post the answer keys for the second semester on D2L. The first semester is already posted under final exam resources. And then you should look over these slides that I'm going over right now. Then I have a number of selected slides to review, which are also posted on D2L under the final exam resources. You should review all your notes for both semesters, and you should review the PowerPoint slides, chapters 1 through 19, and the first semester slides 1 through 10 are posted now on D2L. Okay, let's review multiple choice questions. Do the easiest ones first, especially when you're nervous. Skip the difficult ones and come back to them later. Do the easiest ones first. Each question is worth 1 point, so you want to get as many correct as you can. Think what is the correct answer, or determine the correct answer, or calculate the correct answer before you look at the choices to avoid confusion. Your first inclination is usually the right one. So if you're not sure whether or not to change your initial answer, I would say don't change it unless you have a good reason, unless you see you made a mistake somewhere. And I can't tell you how many times students had the right answer, they erase it, and they put the wrong answer. I recommend you check your work 3 times. Make sure you did, especially the calculations, make sure you didn't make any mistake. And again, it's better to guess than leave something blank. Use the same letter for all your guesses. It makes no sense to hand in a question, hand in questions that are unanswered. It makes no sense. Just guess. And remember, when all else fails, think. Take a deep breath, relax, use your scrap paper, draw a picture, draw a diagram. Okay. All right, here's what it looks like on D2L under the final exam resources. It's the last module, final exam resources. So we're going to have the comprehensive review, which is what I'm doing right now. Then I'm going to go over selected slides. I have some take-home points for you. I have life lesson slides. You have the answer keys for the first semester, and I'll put the answer key for the exams for the second semester. And when you click on this baby, it'll open up PowerPoint slides 1 through 10, the first semester. And of course 11 through 19 are already are here under these modules. Okay, let's look at our course summary. So we looked at the scientific method, significant figures. Remember, when you're adding and multiplying or dividing, conversion of units using the factor label method. We looked at atoms, molecules, and ions. We looked at chemical reactions and stoichiometry. Stoichiometry is predicting, knowing how many grams or molecules of reactants, then you can calculate how many grams or molecules of products you'll get. That's stoichiometry. Gases in the molecular theory, and it nicely explains phase changes, going from a solid liquid into a gas. Very good theory. Thermochemistry involving heat, electronic structure of atoms. Remember, we said that the atoms have a crown of stars around them, and those stars are the electrons, and they're all arranged in a certain pattern, amazing patterns. Of course, we looked at the periodic table, chemical bonds. Remember, we got polar, nonpolar, ionic. And at the end of the course, we learned about a coordinate covalent bond, states of matter and intermolecular forces, properties of solutions, and also involving calculations, chemical kinetics, the speed and pathway of reactions. Usually they take place in more than one step. Chemical equilibrium, there's a forward rate and a reverse rate. They go forward and backwards, and eventually they hit an equilibrium where every time one goes forward, another one comes backward. We looked at acids and bases, buffers, titration, and then solubility equilibria for salts that are very, very, very well, they're insoluble, but they're just a tiny, tiny, tiny bit does dissolve, and the part that does dissolve is in an equilibrium situation. And then thermodynamics, remember we're talking about our free energy, entropy, enthalpy, redox reactions, and electrochemistry. And of course, our last chapter was nuclear chemistry. Now we're going to move to selected slides. All right, now I'm going to move to, this will be posted on your, this is, excuse me, this is posted on D2L, selected under the final exam resources, selected slides to review. So I'm going to open that up, and I'm going to enlarge it. All right, so here I picked out slides from all of the chapters that are particularly important. Okay, so the metric system, make sure you know what kilo means. That's the one we use the most, 1,000. Centi is 1/100th, milli is 1/1000th. Okay, now there won't be any questions about converting from Fahrenheit to Celsius or Celsius to Fahrenheit. Don't have to worry about that. We're really interested in these two scales. So the freezing point in Celsius is 0. That's how it was designed, and boiling is 100. And we notice that it's 273 Kelvin for freezing and 373 Kelvin for boiling. So we know that it's 270 to go from Celsius to Kelvin. You got to add 273. And remember, on all our equations, we got to use Kelvin in the equation, because that way we avoid zero or negative numbers, which is the case with Celsius. So we have to have everything in Kelvin. And remember that absolute zero, which you can't really reach, is 0 Kelvin. And remember, we learned that that's the third law of thermodynamics, where all motion ceases. Entropy is 0 as you approach absolute 0. That was the third law of thermodynamics. Notice that the size of the Celsius degree is the same as the size of the Kelvin. So it's 100 between 0 and 100 in Celsius, and 100 between 0 and between 273 and 373. Okay, our beautiful periodic table. You should know the different categories here. Metals, non-metals, transition metals. This is alkali, alkaline earth. We got the noble gases, got the halogens. Okay, you should know that, be able to compare sizes of atoms. So you should know, and just take a picture of this in your mind, that as you go down the table, they get bigger because you're adding shells. You're adding shells. Over here, you're in the same shell, but each one has one more proton, which has a much, so the attractive power of the nucleus gets bigger and bigger because you have a stronger and stronger positive charge, and it pulls in the electrons, and so it gets smaller and smaller. You should look this over, and again the radius goes down, it gets smaller. This way, radius is how we measure. It's a half of the diameter of the atom, but and just what I said. And you go this way, they get bigger, and non-metallic gets bigger that way, metallic gets bigger that way. Electron affinity, just think of electron, the electron negativity, that it increases as you go this way, and electronegativity increases as you go this way, a stronger attraction for electrons. And ionization energy, it takes much more energy to remove electrons as you go this way. The atoms are smaller, they don't want to give up those electrons, got a strong positive nucleus. Okay, balancing equations. So, remember the rules. Choose the atom to balance first, identify the molecule with the most atoms, balance the atom with the most atoms in that molecule, continue to balance until the entire equation is balanced, and remember, balance oxygen last. Now, the equation you'll be asked to balance is a little bit difficult, so if you get stuck, come back to it later. Don't spend 15 minutes on trying to balance the equation. Okay, remember, all the questions are worth the same. But if you follow this method and balance oxygen last, It makes it easier. All right. Okay, remember our mole conversion chart. So you should be able to go, given grams, you should be able to go to moles by dividing by the molar mass. Okay, and if you're giving number of moles and you want to go to grams, you multiply by molar mass. Or involving molecules or atoms, if you're given moles and you want to know how many atoms or molecules, you multiply by Avogadro's number. Or if you're given the number of molecules or atoms and you want to go to moles, you divide by Avogadro's number. And if you're over here and you want to go to mass, you've got to go through moles first. So this might be good to draw on your scrap paper when you get your exam. And remember the rules for solubility. The ammonium ion and group 1A ions are soluble no matter what negative ion they pair with. They're always soluble. They're always spectators. Same thing for nitrates and acetates. They never form precipitates no matter what the positive ion is. Once you put them in the water, they're spectators. They just float around. Excuse me. Okay, and then we get to chloride, bromide, iodide, which are almost always soluble, no matter what they're paired with, no matter what positive ion they're paired with, except for LMS, lead, mercury, and silver. And sulfates are almost always soluble, no matter what positive ion they pair with, except with Castrobare, calcium, strontium, barium, and lead, LMS, lead, mercury, and silver. Hydroxides, on the other hand, tend to be insoluble, except with group 1, because group 1 is never forms precipitates, and the lower group 2 cations don't form precipitates. But other than that, hydroxides tend to form precipitates. Okay, and remember our ideal gas law, PV equals nRT. And the beauty of this is that, remember, N is moles. The gas constant was given. It's given on your reference page, and you've got liters, atmosphere, moles, and Kelvin as units, and that tells you then that pressure has to be in atmosphere. Can't be in millimeters mercury. Volume has to be in liters, not milliliters. And temperature must be in Kelvin, not Celsius. And these little units here tell us that. Okay, so PV equals nRT. So if you have a problem involving pressure, volume, temperature, you ask about moles, it's this equation. And again, in all these equations, everything will be given and you solve for the unknown. Oh, the beautiful block chart. This is beautiful. Remember, the first two columns is the S block. This block here, the tall tower, is a P block. The D block is a transition, and the F block, although we're not really dealing much with the F block. Okay, beautiful table. Then we get to our quantum numbers. You don't need to know the names, but you need to know the symbols and identify the N, the L, the M sub L, and the M sub S for any electron on the periodic table. Okay, so you need to be able to identify the four quantum numbers N, L, M sub S for any. Remember that if it's in the S block, well, first of all, N is basically the period or row in the table. So that's the first row, 2, 3, 4, 5, 6, 7. And remember, when you get to transition, N decreases by 1. Okay? Then we get to the L, so N, now L, so L for the S block is 0, 0. For any of these elements, it's 0. For the P block, all of these, L is equal to 1, and for the D block, L is equal to 2, and if we don't use F much, but L would be 3. Now M sub L, remember how that works. M sub L basically is minus L to L. So if we're looking here, since L is 0 for this block, then each of these are M sub L is 0, 0. Over here, it's going to go from minus L to L, but twice. So minus 1, 0. So L is 1, so it's minus 1, 0, 1, minus 1, 0, 1. Remember, because each electron gets put in, one electron gets put in first, and then they pair up. Same thing over here for M sub L. Since L is 2, M sub L goes from minus 2 to 2. goes from minus L to L. So minus 2, minus 1, 0, plus 1, plus 2. And then we do it again for the second. And, you know, the electrons pair up. So we do it again. Minus 2, minus 1, 0, plus 1, plus 2. So that's m sub L. And then the last quantum number is m sub S. Okay, so what we do for the S block here is we say, okay, the first column is going to be a plus 1/2. The second column is going to be a minus 1/2, and that means they're opposite spin. And then when we go to the P block, m sub S, the first three are going to be plus 1/2, the second three minus 1/2. So the first three are one spin, and then when they pair up with opposite spins. When you go to the D block, so you got 10, so the first 5, 1, 2, 3, 4, 5 are going to be plus 1/2 spin, and then when they pair up, they're going to be 1, 2, 3, 4, 5, they're all going to be minus 1/2. So for any electron on the table, for any atom on the table, at least for any electron on the periodic table, you should be able to tell the 4 quantum numbers. And they have to be different, remember, because the spin can't be the same. If they pair up, they have to have opposite spin. So no two electrons can have the 4 same quantum numbers. They could have 3 the same, but the last one has to be different because they have to be of opposite spin. Okay, now remember our using this notation. So using our electron configuration notation, you should be able to, for any element on the table, give the electron configuration. Okay, according to this, and the S block and the block chart really helps with this. And remember that the electrons first go in unpaired and then they pair up. Okay, it's sticking, and then they pair up. So first one electron goes first and then they pair up. But you should be able to write the electron configuration for elements on the periodic, any element on the periodic table, although we basically worked with, I think, up to here the first 4 or 5. You won't be asked to do 6 or 7, so just the first 5, okay? And if you use your block chart, it makes it very easy. And then electronegativity, remember this is the most electronegative over here, and then francium is the least electronegative. So this here you have strong attraction for electrons. And remember, for nonpolar covalence, basically 0, the same element, but it could be 0.5 also. Would be not if the difference in electronegativity is between 0 and 0.5. Example would be oxygen, O2, the same element. So electronegativity difference is 0, and then if it's basically 0.5 to 1.7, it's going to be polar covalent, and that's going to be 2 nonmetals. If the difference is greater than 1.7, then it's going to be a metal and a nonmetal, and it's going to be ionic with an actual transfer of electrons. Here we have equal sharing. Here we have one of the atoms has a greater pull on the electron. So it has 2 poles that way. It's polar. And remember that metals in group 1, they form +1 ions. In group 2, they form +2 ions. In group 3, +3 ions. And then elements in group 7A, they gain 1 electron and become a -1 charge. Nonmetals, when they form ions, they form in group 6A, they form a -2. And of course, the whole point of that is to get an octet, 8 electrons in the outer shell. And these 3, by losing these electrons, and then the next shell is full. And so they become stable and lower energy. Remember our phase changes, so melting, freezing, and evaporation. You can say vaporization, you can say boiling or evaporation, either way. And condensation goes the other way. And then these 2, which are less common, but you should know them, sublimation goes from solid to gas, and going the other way, solid to gas, is deposition. And remember this chart here, which is our shows the different phases as you go from solid liquid to a gas. Here the temperature can be increasing even though you're below 0. When you hit melting, no temperature change. When you hit vaporization, no temperature change. And we have different formulas for determining the amount of energy in each of these cases. Remember, this is going to be MC delta T, and this will be the delta H times the heat of fusion constant, and so on. Okay, so make sure you know how to calculate the amount of energy in each of these sectors. Remember, the energy added this way will be this. If you're cooling, the same amount of energy gets released going back the other way. Also notice the picture of the atoms, what's happening. Here you have the solid, then it's starting to melt, then it becomes all liquid, and then it starts to vaporize, and then it becomes all gas. The particles are very far apart from each other. Oh, the triple point graph. Remember that at the triple point, you've got liquid, solid, and gas all at the same time. And you should know that underneath this line, you got water vapor. In between these two, you got liquid water, and here you have the solid. Critical pressure. The critical point would be the temperature above which you can never make it a liquid. Okay, and that's the critical temperature here is 374, and the pressure that matches it is the critical pressure 218. But above this temperature, you can never make it a liquid. Okay, remember our rate expressions. And these rates are all equal to each other, so we take 1 over the coefficient, the concentration of the reactant over the change in temperature, change in concentration over the change in temperature. These are negative because they're being depleted, and that's what happens with the reactants, and these are positive because they're being formed. Remember our rate law. Now we'll get to the rate law for a chemical reaction. R is equal to K. K is unique for each chemical reaction. You do the concentration of A raised to a power, which is called an order. Concentration of B raised. You're only interested in the reactants, and M and N can only be found by experiment. You can only find them by experiment. Remember, to get the total order of the reaction, you add up the exponents. So 2 plus 1 is 3. That's third order. Here it's just 1, so it's first order. And remember this particular graph where this shows the activation, the amount of energy. Energy is on the y-axis. This is the amount of energy needed for the reaction to occur. Remember that we have the activated complex, and without a catalyst it takes more, but then you lower the activation energy with a catalyst. Remember, this is the energy of the reactants, this is the energy of the products. The difference between them is the delta H, and notice here the products are of lower energy, so it's an exothermic. It gave off energy. Then equilibrium expressions. This is more recent. So to find the equilibrium constant, we take the concentration of the products over the concentration of the reactants, and each raised to a power equal to the coefficient. It's called the law of mass action, or the equilibrium expression. So for example, this equation here, it's going to be concentration of NO2 squared over the concentration of N2O4. And remember, we only have gases or aqueous. We don't include solids or liquids. We don't include solids or liquids in the equilibrium expression. Le Chatelier's principle, yes! If somehow you change a system at equilibrium, it will shift to the right or to the left to reestablish the equilibrium. In other words, it wants to replace, replenish, or consume to offset the change. And I'm just highlighting this so you can go into it in more depth in your study. Remember the Bronsted-Lowry theory. The proton donor is the acid, the proton acceptor is the base. We did look at Lewis theory when we were talking about the coordinate covalent bond in ligands and complex ions. In that case, you can define the acid as the electron pair acceptor and the base electron pair donor. So we just looked at this in one instance, and that was the complex ion with the ligands. You should memorize the strong bases and the strong acids. Remember, this is the first column, second column. and you should memorize these. And then remember how we calculated pH. So for strong acid or strong base, it's easy. It's pH is a negative log of the concentration. It could be H plus or H3O plus, same thing. POH is that, negative log of the concentration of OH. And then you have to find the pH once you get the POH, subtract it from 14. For a weak acid or weak base, we use these equations. Remember, they're shortcut equations. And then once you get the concentrations of H plus and OH minus, then you use these equations. And for buffer, and again, that's on your reference page, or you could also write it that way. But this is the way it is on the American Chemical Society exam reference page. That's the base, that's the acid, that's the pKa, Henderson-Hasselbalch equation. And remember that the P of anything is just a negative log of it. So the pKa is just a negative log of the K sub A, which is the equilibrium constant for the weak acid. Remember that K sub A times K sub B is 1 times 10 to the minus 14, as is the hydronium ion concentration times the OH minus concentration is 10 to the minus 14, and pH plus POH is 14. Okay, remember our solubility product, we don't have the bottom part of the reaction because it's a solid, so we just have the concentration of the products, and we call it a solubility product because there's no bottom to the fraction, so it's just one thing multiplied by another. And remember here, like if you've got two CLs, then you have to, just like as always in equilibrium, you put the concentration, raise it to the power equal to the coefficient, which is 2. Okay, remember oxidation and reduction. Oxidation is loss, oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. And then we can also say that oxidation is an increase in oxidation number, and reduction is a decrease in oxidation number. And I gave you rules for determining oxidation number. You should make sure you know those rules. And then we go to the voltaic cell or the galvanic cell. Remember, oxidation is always at the anode, reduction is always at the cathode. Chemical energy is getting converted to electrical energy. This is how a battery works. And in this particular case, so the zinc gets oxidized, so this is getting smaller and smaller. It gets eaten away, and copper, on the other hand, the copper ions in solution, they make this grow. Remember that the porous disk or the salt bridge allows the negative ions to flow this way, because as electrons flow from the anode to the cathode, you build up an electric charge, and so to balance that, the anions flow into the other cell. And remember, the electrolytic cell is just the opposite. You just add a current, and then everything goes in reverse. Remember that our three equations are all connected, so we can connect the cell potential with the free energy with the equilibrium constant, and there's our beautiful equation, delta G equals delta H minus T delta S. Remember that little 0 means standard conditions, 1 molar, 298 Kelvin, room temperature, and 1 atmospheric pressure. And this is basically predicts the beauty of this equation by Mr. Gibbs was that it predicts whether or not reactions or processes are spontaneous. So this is a beautiful discovery. And this equation here tells you the relationship between free energy and equilibrium constant, so you can predict the position of equilibrium with that equation. But all three of them are connected with each other, as we talked about. Remember how we get half-life. Okay, we've just gone over that. Okay, now what I'm going to do is go back to the slides that we were on. So we're going to go back here now. So those are selected slides that I went through. So let's go back over here. And so this is where we left off. And so you should go through these, look at the, the different topics in each of the chapters. I won't go through them now to save you time, but you should read through those. Same thing here for stoichiometry, the different things you should know for chemical reactions. The gas laws, make sure you know this one, P1V1T2 equals P2V2T1. Notice it wasn't on the reference page, but the beauty of this equation is if a problem involves pressure, two sets of pressure, volumes, and temperatures, you know this is the equation. If it just involves two of these, you cancel the third variable. For example, if the question just involved volume and temperature, you could cancel the pressure because that's held constant. So you just need to know one equation, P1V1T2 equals P2V2T1. As I said, you can sing that in the shower. P1V1T2 equals P2V2T1. Okay, these are the topics for thermochemistry. And then we get into the quantum mechanics. Okay, being able to draw Lewis structures of atoms and molecules. Remember that every atom needs to have an octet. And when you're drawing it for a molecule, the number of electrons you started with, you have to have the same number in the final molecule. And then we looked at the VSEPR theory and predicting the different shapes and polarity. Okay, then condensed phases, solids and liquids, and so on. So look through these solutions. Kinetics, the topics for kinetics, equilibrium, acid base, titration and buffers, thermodynamics, electrochemistry, and nuclear chemistry. And these are some of the equations that we worked with, so you should look through all of these equations. Same thing here, there's the MC delta T equation. Speed of light is equal to the wavelength times frequency. Energy is equal to Planck's constants, which will always be given if you need it, times the velocity. You're not going to need to use the Rydberg equation. This is the equation for de Broglie's wavelength. And heats of a reaction, remember how we did that. Okay. And remember the definitions for molarity, molality, percent, composition, mole fraction, the vapor pressure lowering, boiling point elevation, freezing point depression, and the M1V1. If you have a problem involving molarity and volume, and then a new volume, and what's the new molarity? Use this equation, M1V1 equals M2V2, and essentially it's the number of moles you start with equals the number of moles you finish with. Okay, some more equations you should look through, and again, this was the form that we looked at it. On the reference page for the ACS exam, American Chemical Society exam, they put it in a different form, but it still works the same. But if you want me to put it in this form for you, I can do that. Remember our half-life equation, 0.693 over K. There's our pH and pOH equations, Henderson-Hasselbalch equation for buffers, and the Gibbs free energy, and the other various equations. E equals mc squared. And remember, for radioactive substances, we get the half-life is 0.693 over K, and since it's a first order, then we're going to use this equation as we use in kinetics. Okay, and as I said, welcome to the Fellowship of Those Educated in the Wonders of the Chemical World. And if you'd like to, you can play this beautiful song again by Louis Armstrong, that it is a wonderful world and we got to love each other more. Okay, now I'm going to go back to our D2L, and I'm going to look at our take-home points, which are all right. Now we're going to look at our take-home points. This is also posted on your D2L and the final exam resources. First take-home point: order and harmony in the material world. We've seen that all year long. The most important thing I'd like you to take from this course is a sense of awe and a sense of wonder. It's amazing how everything is put together in the material universe. It's incredible, and it reflects the magnificence of God the Creator. Of course, we learned the language of chemistry, didn't we? So now you can say, I know a new language. I know the language of chemistry, all the different terms and definitions that we used throughout the year. We talked a lot about study skills and exam taking skills. Not a good idea to wait to the night before the exam. Better to study a little at a time. And I talked about the exam taking skills for multiple choice questions already. Ladies and gentlemen, I am very happy to write a recommendation for you. I do it all the time. I just had one of my students get into a summer program, CARIS, in a summer program in Johns Hopkins on bioethics. I think it's a 10-week program. It's fantastic. She got in, and I wrote a strong recommendation for her. But I do strong recommendations. I know you very well, and I can indicate all your strengths. I know your strengths. I won't talk about any weaknesses. As a matter of fact, that when they ask me, does the student have any weaknesses, I usually say none. So they can't use anything against you, all right? And some of you will be in the medical field, doctors, physical therapists, physician's assistants. Well, not veterinarian, but if I'm ever your patient, please take good care of me, okay? Please take good care of me. All right? And now at this point, I'd like you to, I have some other things that I want you to take from the course, and it's going to be some life lessons. Very important life lesson from Mr. Aristotle. Well begun is half done. If you get all your materials together, you sit down and you begin, and then you're in good shape. Then it's much easier to finish the task. The hardest part is getting ready. It's kind of like it takes a little bit of fortitude. Say, I'm going to do this now. I don't feel like it. I start, and once I start, then I'm on my way to finishing it. Well begun is half done. To be early is to be on time. This is so important in life. Employers don't like employees that come late. To be early is to be on time. And you did great this year, by the way. This semester, the attendance was very good. Nobody got perfect attendance this time. Nobody had fewer than 2 absences. And I usually, for perfect attendance, I allow 1 absence. So we didn't make it. However, you're not penalized. If you had 3 absences or less, that's considered full attendance in terms of the grading. But anyway, you've been very good about being on time this semester and even being early. And it's great to come when you come early to class because we can talk a little bit. And here's another thing I learned from a lifeguard this year. She said, better late than never, but never late is better. Never late is better. When all else fails, think. I can't tell you how every day, well, very frequently I use this. A great basketball coach taught me this, Morgan Wooten of DeMatha High School. He's in the Hall of Fame. And one of his teachings was, when all else fails, think. So don't panic, think. When was the last time I had those car keys? Or you're solving an exam. You're stuck on a question. Okay, relax, take a deep breath, think about it, come back to it later. And as you know, when you come back to it later, your default mode in your brain is still working on it, and you come back to it later, and sometimes you see it. Draw a picture, write down what's given, think, relax, think about it. You can do it, and I want you to grow in the confidence that you can solve challenging problems. You can solve it. Just think about it a little bit. Take a deep breath. And the final life lesson I want to tell you is our weapon is love. Our weapon is love. And Louis Diadio, a gentleman who lived to 98 years old, a great man, he was very involved in civil rights in the 50s, and then he got into the pro-life movement. Anyway, one of his pieces of wisdom is kill him with kindness. That's our weapon. We kill him with kindness. So that's the final life lesson that I want to mention to you. Okay, now I've gone back to D2L and I've hit on the final exam resources. But before I mention this again, I want to now give you the question. I want you to send me an email with your answer. The question is to tell me one thing you've learned this semester or this year in chemistry. So if somebody were to ask you, what did you learn in chemistry? Just tell me one thing you learned. It can be anything. Okay, so I want each of you to send me an email, what I learned in chemistry, and just in a sentence, one sentence is fine. Tell me something you learned this year. And actually that's helpful for me to get your feedback on what things really struck home for you. And this also will tell me that you watched this video. Because you're required, because this is your last class, and as I told you, I'm shuffling off to Buffalo for my niece's wedding, so this is your final comprehensive review. And if I could, it didn't work, but I wanted to play the song from the Stylistics, which is entitled "Let's Put It All Together." And one thing about a final exam is you get to study, and especially when it's both semesters, you get to pull together everything you learned for the whole semester. So it's very satisfying to put everything together for the whole semester. And as you know, things we did earlier in the semester, we built on all throughout the year. Okay, so let's go over to the final exam resources right here in D2L. So we've got the comprehensive review for the final exam, which I went over, selected slides, which are here, take-home points that I went through, the life lessons. You've got the answer keys for the first semester, and then I'll post the answer keys for the second semester exams Wednesday afternoon. And here we have the PowerPoint slides from the first semester, so you can see we got 1 through 9. So to close things up, remember that chemistry is the central science because everything is made of stuff. It's not that chemistry is more important, but everything's made of stuff. So in that sense, it's essential science. And then what I wanted to tell you is that, and I've mentioned this before, you know more chemistry than anyone who has ever lived or walked on the face of the earth up until the 1900s. And much of what we learned primarily comes from the last 400 years where we made huge advances, discovering all the elements and many other things, protons, electrons, neutrons, and all that kind of thing, electricity, and so many things that we've learned. But you know more chemistry. Even today, you probably know more chemistry than most people that are walking on the face of the earth. So you've learned a lot. You've learned a lot about how the greatness of God's goodness.